Good evening, everyone. Good evening, boys and girls. I hope you had a wonderful weekend. Right, today we want to resume with our topic on Loci with specific attention on the helix, but we want to look specifically at the chute. Right, like I said, we are still looking at the loci and the helix in general, but with regards to the chute in particular. Right, some would call it a chute, some would call it a chute, right, as long as we understand each other. Right, by definition, a chute is referred to as a sloping channel or a slide for conveying things to a lower level. Also, for recreational purposes, you'll find at parks such things as slides and water chutes. Those are specific applications of the helix, but with regards to specific uses. So today we want to look at the specific construction of a chute from the information that will be given up until we complete that. Remember last time we looked at an auger, but now we want to look at the chute. Right, let us look at the specific constructions with regards to this task. But just before then, right, I want to reiterate this very good statement of ours. I hear and I forget, I see and I remember, I do and I understand. Like always, I want you to be practical with regards to your approach to engineering work, and in particular, engineering graphics and design. Remember, this is a very important subject linked to the world of industry and with regards to engineering. At some point, I refer to this subject as the language of industry, right? You can only master a language by using that language. So you cannot master this language without a proper use. So we want to look at the proper use of this particular language so that you'll be able to speak it properly. Enjoy the lesson. And thank you. Let me just say law. Right, we have got a specific task from one of the workbooks that we are using. Right, to be specific, it's by HSE. That's the workbook that I'm using right now. Right, given information, the front view of the shaft and the starting point of a chute. The specifications are as follows. The direction, it's right-hand direction. Turns, it's 1.5 turns. The outside diameter, right, of the auger, which is basically again being used now to refer in the construction of a chute, okay? Right, which is diameter 90, right? And this also, the outside diameter is also linked again to the chute, okay? The chute starts at point A, right? Add a 10mm ridge to the outside of the chute. Right, like I said, if you go to some parks, you'll find that our little ones would slide from the top going downwards. And just to make sure that they are not going to be endangered, there is some kind of an edge for safety purposes, which is provided on that slide so that they would not fall over. Right, that edge that we see in real terms with regards to a slide at a park is what we are talking about right now. So we need to establish that one as well. Of course, it would come as part of the helix as well, or it's in the form of a helix. Starting at point A, right? If we take this one up a little bit, you have got point A here, which is at the bottom. Right, remember the positioning of a point at the bottom or at the top. It has got implications with regards to how we number the top view. Right, show all the necessary constructions and show all hidden details. We are going to look at that now. Right, so what you need to do first, right, just define a line via the middle of your space. Right, just a faint line like this. Then you also, right, somewhere here, just draw a faint horizontal line like that. Take this one. There you go. Right, we are told that the outside diameter, right, remember we talked about the outside diameter when we were talking about the auger. Right, so you measure 90, but radius 40, 45. Right, if you don't have enough space, right, you can just draw a semicircle, okay? Maybe that's what I should just do for now. Just draw a semicircle, but fortunately I do have enough space, so I can draw a complete circle. Open from the center. Right, then draw a circle like this. There you go. The diameter of the shaft, which is the core diameter, is diameter 20, but which means radius 10. Take this one up slightly. There you go. Right. But now what we need to look at is, right, if we have got the distance from here to there is 90 millimeters, okay? But we know that if the point is starting here, it should cover a height of 90, okay? Right, which is 90 millimeters. Let me just sketch it here. Right, let me do this. Right, we have got the core diameter or the shaft like that. Right, from this point, that's our point A, which is point 0 as well. Right, we have got the outside diameter, which means another point would be here, okay, which is also point 0. But at some point, the point would be 10 millimeters from here, which is the starting point, but which if we draw, would say this is again point 0. The point 0 should cover 90 millimeters also going upwards, right? So if the point is starting here, it's not going to end at this level. It is going to end 10 millimeters after the 90 millimeter mark. So it's going to end like that, okay? Right, so that here also we cover the same distance of 90 millimeters. From here to there, this is 90, right? So from here to there, that's 90. Then from here also to there, that's still 90. But if we start 10 millimeters from the ground or from the starting point, we should also end 10 millimeters after the end part, okay? Such that we still maintain 1.5 turns as well as a distance of 90 millimeters. So overall then, we need this distance from here to there, which would be 90 plus 10, which would be 100 millimeters. So that is what you should define first before you do the you draw anything. So I'm going to measure 100 millimeters. Measure 100 millimeters from here to there. Mark that. and mark that. There you go. Right, once you have done that, you can even bring this one down faintly, like that. Bring this one down also, faintly, like that, okay? Right, so we have got from here to there, that's 100, okay? Now, we know that when we are saying, right, the number of tens is 1.5 tens, right, which would give us 18 divisions, okay? Right, 18 divisions like this. Right, so 1.5 tens should give us 18 divisions, and this 1.5 or 18 divisions is basically equal to 90 millimeters, okay? Right, what about now if we have got 100 millimeters? How many divisions do we require? We can use simple proportion, okay? Right, whereby you would say, okay, 100 over 90 multiplied by 18. Then we get the number, or you simply cross multiply like that. 100 multiplied by 18 divided by 90. Let's see how many divisions we are going to get. Right, we are going to get 20 divisions all in all from here to there. That's 20 divisions, okay? Right. The other option that you can do, right, is to say, okay, if we have got 90 divided by 18, right, would see how many millimeter spacings we are going to have. So 90 divided by 18, you would find that we will get 5 millimeter in terms of the spacing, right, from one point to the other, right, in terms of the number of divisions. We all know that the divisions, they are supposed to be 18 divisions. One complete 10 is equal to 12, and half a 10 would add another 6, which will altogether would give you 18 divisions. So then you would say, right, if we add 10 millimeter, right, 10 millimeter in terms of the distance on top of the 90, 10 divided by 5 millimeter divisions, right, we are going to get how many more divisions? 2. 2 plus these ones, which is 18, would end up getting 20, okay? So if we divide 10 millimeters divided by 5 millimeters, we'll get 2 additional divisions. 2 additional divisions plus the 18 that we already have, right, would end up now getting 20 divisions. So with the 100 millimeter that we measure from here to there, we now want to divide this into 20 equal parts, okay? Right, let me just bring the core diameter down as well, like that, like that. All right, unfortunately, I don't have much space, so I can squeeze it here. Right, let me squeeze it here so that I don't compromise my drawing space a lot, okay? There you go. Then I need 10 divisions, but I'm going to do it at intervals of 5. There you go. Connect this one to there. There you go. Right, remember, these divisions, right, you'd find that certain rubrics or certain marking schemes would require the division, the graphical representation of that division, right, in terms of the height. But like I said already, right, you can say 100 divided by 20, you would find that this would be 5mm divisions from here to there, 5mm, 5mm, you can actually measure. But if there is a mark allocated for this, you'd find that you would lose that mark, okay? Right, then you straighten this. Like that, okay? Right, since I'm starting at the bottom, this will be my point, right? A, which is also point 0. Right, so 1, 2, 3, 4, 5, 6. That's my point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is another 0. So the distance from here to there, that constitutes our pitch, okay? Or our 110, then 1, 2, 3, 4, 5, 6, right? We have got that. Now, remember, at some point, you are going to start here. So this will be your point 0, right? And you end here, okay? So these two divisions basically are referring to that 10mm edge that was talked about. The other thing that we need to do, we divide this into 12 equal parts via the sending. Take this one down. Right, okay. What I'm going to do, I'm just going to focus on this lower part since we don't have enough space at the top. Right, like that. Right, there you go. That's our point A, which is our point 0. Right, under normal circumstances, we said that when it is right-handed, it should go in a clockwise direction. But now this point is starting at the bottom. So we are going to number this point number 1, right? That's 3, that's 6, that's 9. So we are going anti-clockwise like that, such that when you are observing from there and this thing is turning in a clockwise direction, the first point that we will see is point number 1 being viewed there, okay? Right. From there, we can project down, project like this. Forget about the inner shaft or the inner cylinder, but just concentrate on the outside for now. Maybe something that we should not forget. That's the center line. There you go. Right, okay. Right, like I said, I'm just going to concentrate because they are the same points at the top, okay? Right, so this is point 1, right? This is 0, this is 1, so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, and 6, okay? Right, like that. Then nicely, you join these points. Don't worry, even if you miss the points with your first draft line, right, you would correct as you outline. Right, I'm going to start now at this second 0, such that I'll be able to end there. Sorry about that. Right, so this is point 0. That's 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, 1, 12, 1, 2, 3, 4, 5, and 6, like that. And then you connect these points. There you go, okay? Right, now once you have done this, right, you may even outline the helix which is going to the right. At this point, you can outline the helix which is going to the right. Right, since it is right-handed, so we are going to outline this up to there, from here to there, and also from here to there, and also from here to there, okay? Right, you start by outlining that which is going to the right. So I'm going to start. Like that. There you go. And this one too. There you go. Right, okay, right. Since it's right-handed, you concentrate on the big helix, which is going to the right. Once you have done that, you can even close this. And close this. And that. Right. The next thing that we want to do, right, is to define the helix, which is starting on the shaft. Remember, on the shaft, there is only one helix. Right, so let's project downwards. Like that. Right. So this is point 0. Remember, there is only one helix around the shaft. So 0, 1, 2, 3 is common, 4, 5, and 6, 7, 8, 9 is common, 10, 11, 12, 1, 2, 3, 4, 5, and 6. Like that, okay? So you have got this point. Now you connect this point faintly also to create the helix. There you go, okay? Right. Once you have done this, now you outline that part of the helix which is going to the right, the small one which is going to the right, it's from here to there, right, which is not affected by the big helix that we have already outlined. So I'm going to outline from here to there, right. Then I would see this one just a little bit here, okay, just a little bit. But this one is now going to the left, so I would outline this one also, right, like this. Then I stop. Then I would see partly that when it is going to the left, okay? Right, when it is now outside the shaft, okay? Right, so from here, right, I would see the helix, I would see the helix. Thereafter, you define the rest of the shaft that you will be able to see. The moment it is going to the left like that, it means from here up until there, the shaft will be visible. So I'm going to outline, let me use a different color. From here to there, the shaft is visible, okay? Right, from here up until I get at this point, the shaft is also visible. Like that. Right, then also take this one out. Right, now if we are going to make sure that this is practical, we are also going to extend this shaft, okay, by how many millimeters? By 10 millimeters, so that it can support, right, the edge that we talked about. So we are going to extend this to this point and like that. Then we close at the top. We also close at the bottom. There is nothing that is going to affect the shaft here, so we outline this part. Now, the next thing that you're required to do, right, you will see this, right, is on the outside, is not affecting anything, right, by virtue of this line crossing this line there, okay, which means this one, this helix is a hidden detail. So I'm going to do this. Like that, stop there. Right, this one is not going to affect anything, it's on the outside, so I'm going to do this like that, okay, right, and I'm also going to close here like that. Then this one, you will see it partly, then it crosses this one, so therefore it becomes hidden like that, right. Then the other thing here, this is where you start in terms of the slide. You are going to, we are going to see you partly here and also there, then you fall on the other side, okay? Right, the rest now should be defined as hidden details. So from here, I'm going to show this one, hidden detail. Where else do we have? Right, the shaft did not disappear. So where you don't see the shaft, what it means basically is it's hidden, that part, okay? The same applies here. Right, and you also come here and you show hidden details, but you do the same. There you go. Right, so now this is a typical example of what we refer to as a chute or a chute. Right, you would slide from there, we don't see you, we see you briefly there, then you turn around, then you come out on the other side, okay? Right, so I hope you are mastering this technique such that in an exam, right, you should be able to do it with confidence. This is a favorite for examiners. They want to test this concept quite a lot, okay? Right, now that we have this, we have covered everything, the outside diameter, which is 90, right? Then the chute starts at point A, which is at the bottom, and we reversed in terms of the rotation. Then the other thing, right? We added a 10 millimeter ridge from here to there, that's 10 millimeter. We also need to show hidden details here, okay? Such that that would be the edge, and we change this one now. We outline from here to there, right? In terms of that center line, to show that this is where you are starting in terms of your sliding, okay? Right, of course, in terms of our construction, we started here, but we ended there. Right, now we are done with our first task. We want now to move on to the second task. And this time around, we are going to move with a bit of speed. Right, the first thing that you need to establish, right, we are given the height from here to there, that's 90, right? But we can see that there's an additional 15 millimeters and also 15 millimeters from there. So the total height that we require is not 90. The height would be 90 plus 15, which would give you 105, okay? So in terms of our constructions, we need to determine with the height from here to there, which is 105. We are given the shaft diameter or the core diameter is 30, okay? But the outside diameter is not specified. But we know that it's from here to there 30, from here to there is 30, from here to there it's 30. So altogether it's diameter 90, okay? Right, this time I just want to bring this one down a little bit so that the focus is right. Use a pencil like that. Push this one. We are done with the first one. There you go. Okay. Right in the middle. I'm not going to draw a complete circle, but I'm just going to draw a half circle, which is a semicircle. Remember, we said the outside diameter is diameter 90. Right, so I'm going to measure 45. Like that. Then 15 is the radius. Stand here. Open your canvas and describe. Okay. We'll do the same. There you go. Right, it's not complete, so I'm going to do this. That's the center line. Right, just to show that this is symmetrical, I'm going to show the convention like that. There you go. Right. it's left-handed, it's 1.5 tens, right? Remember I said the height is 105. It's 105 here. And there you go. Bring this one down. And also this one. Right, like that. Now, the other thing that we need to consider is the number of divisions. Right, we know that 90 would give us 18 divisions. What about 105? So we are going to say number of divisions, right, is equal to, right, 105 divided by 90 multiplied by 18, okay? Right, 105 divided by 90 multiplied by 18 would get 21 divisions, okay? So we want to divide this height from here to there into 21 divisions. So I'm going to create an angle. These are the divisions. There are marks which are awarded for showing these divisions. Then horizontal divisions. There you go. Okay. Right. We are starting at the bottom again. So there is our point 0. Right. 1, 2, 3, 4, 5, 6. Right. 7, 8, 9, 10, 11, 12, which is 0. 1, 2, 3, 4, 5, 6, which is point number 6. 1, 2, 3. Right. The 3 divisions are equal to 15 millimeters. Right, from here to there. That's 15 millimeters. So you find that our next point is 0 will be here. Okay. But let me just label that one 0 and 0 as well. Okay. Right. You divide the circle into 12 equal parts. Right, in this case, because it's a half circle, we are going to divide it into 6. So that's our point 0, right there. Right, it's starting at the bottom, right, because that is where the start point is, right? So we are going to number anti-clockwise, but since it is a half circle, right, that would still be number 1, number 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, okay? So let me just say this is point 9 as well. Right, the next thing, let's define the center lines. These are marks which you should not throw away. Right, project these ones down. Currently. There you go. Okay. Right. So this is point 0. That's 1, 2. That's 2. Then 3, 4, 5, and 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, and 6. You stop there. Right, you connect these ones nicely. There you go. So from here to there, that's 1 complete 10. Then this is half a 10, which is 1.5. Right. Then you start again from this point. That's 0. That's 1, 2, 3, 4. I'm putting just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, and 6. Okay. But you connect these points. Like this. All right. Now, we have the two helices, right, the big ones. But what you do in this scenario, right, you outline the big helix, which is going to the right. So you are going to outline to the left rather, right, from here. There you go. Right, then the other one which is going to the left is this one. There you go. Right, so this is the only one which is moving and moving away from me, and also going to the left. So I will close this part. Right, come this side, you close the ends like that. Then we also close this one. But in terms of the edge or the ridge, like this. Right. The next thing right now is to project from here, right, in terms of the helix, which is on the shaft. So project. That's 1, 2, 4, and 6 like that. Right. This is point 0. 1, 2, 3 is common. 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6. You stop here, right? That's it. Then you connect. There you go. So what it means basically is, right, if you are looking at this, right, from here now, you can bring this one because it's going to the left. So from this point where it is going to the right, we are able to see the shaft. So let's start by outlining that which is going to the left. This one. Okay. But so from here, we can take this one down. Let me use a different color. That's the shaft. Okay. Then we also show the shaft here. There we go. But the moment it is going to the right, which means the helix is on the other side. Okay. Right, like here. I'm going to take this one up. Take it all the way, right? And also take this one up. Like this. Take this one all the way as well. But what it means, this will be exposed. Right, close this like that, and also come here and initially close that. Then I can go on and outline the rest of the shaft, the helix, even though it is going to the right, but it's not interfering with the shaft. It will come here. There you go. But remember, the end part is this one, so I would need to outline this. If I outline this, I would come here also and expose this. Okay. This is not interfering with the shaft, so I'm also going to outline this one like that. This one too. No, not beyond this. Show that one as a hidden detail. Then from here, let's look at this. There you go. Okay, but this would come here like that. Connected there. Let me show this one as hidden detail. There you go. So this one. There you go as well. I would also need to close this at the bottom. So we will see something there. Then outline. This one is going to the right, so from here, it's all hidden details. Then, though this one is going to the left, but it's now within the outlined specifications of the big helices, like that. Right. Last but not least, we define the hidden details for the shaft. There you go. I did not complete this. Is the hidden detail, okay? But there is also hidden detail here. There you go. Okay. But so the first thing that you need to define, right, are the big helices which are going to the left, then the small helix which is also going to the left. The rest now can be defined as the outline of the shaft. But this is going to the right, it's going to the right, but it's not interfering with the shaft. We have defined the center line, we did draw the top view, then this is what we refer to as the chute. So if you are going to start there, right, we'll see you briefly, right, then here, right, we don't see you, but we see you when you come out like that. So the hand, in terms of the left hand, is defined by the big helices, which are going to the left. If we looked at this one, it was the big helix, which was going to the right. So the moment you see the outlines like that, you can easily identify the hand. Right, boys and girls, I hope you understood the concept of a chute, right? And I'm sure you should be able to apply this on your own through practice. Remember, to master this subject, you should practice and practice and practice more. There is no way that you will be able to master this without sufficient practice work, okay? Right, one can only speak confidently about this subject as a result of continuous practice. Right, you will get your marks through practice. You can only present your work properly through practice. So I urge you to practice and practice and practice more. Enjoy the rest of your evening and good night.
Are you done?
Yes, I am, Melen.
Okay, perfect. Enjoy the rest of your evening. I'll see you again tomorrow.
Okay, thank you. Same to you.
Enjoy, okay? Bye-bye.
Bye-bye.